Hello everyone, I'm Jacob Kauf and I'm the nerd on the street, and today we're setting up a WireGuard VPN server with WebSocket tunneling. Alright everyone, so I'm making this video because I've gotten a few questions in the past about how to set up WireGuard, and I was interested myself in how it could be used for setting up a VPN server. Now, a VPN or virtual private network allows a machine on your local network and a machine on a remote network to communicate privately as if they're on the same network, and it's very common to use VPNs to give yourself increased privacy and security when you're out using public internet connections, or even if you just don't want your own internet service provider keeping track of all the websites that you're talking to. You can route all of your traffic through a VPN server, so whoever's providing your internet connection just sees you talking to the one VPN server, and then all of your connections to the internet are actually going from that server to their final destinations. Now, in the past, I've personally used OpenVPN whenever I've needed a VPN server. However, OpenVPN is a little bit tedious to set up properly, and it's also pretty heavy. It adds a decent amount of latency to your connection, so while it is a tried and true protocol for VPNs, there's definitely been space for development in VPN protocols. WireGuard is a relatively new VPN protocol. Its key features are that it's very simple. It has a code base that is way smaller than the code base for OpenVPN or other alternatives. And it's also built into the Linux kernel at this point. So any Linux-based machine running a mainline kernel can use the WireGuard protocol without having to rely on too many external tools. Now, the downside to WireGuard is that because it's so simple, it doesn't have all of the same features as some other protocols. With OpenVPN, it's very easy to set up your traffic so it appears that you're just talking to a website when it's actually an OpenVPN server. With WireGuard, it's very obvious to a network administrator if you're using WireGuard as a protocol. You're sending UDP packets on a specific port, so that traffic is not going to look like regular web traffic. Because of that, it's currently not possible to use regular old WireGuard on some public internet connections. There are a lot of public networks out there that restrict connections to only HTTP or HTTPS web traffic. However, you can get around that with third-party tools, and today we're going to tunnel our WireGuard traffic through a WebSocket connection that's going to use TLS to make it look like your WireGuard VPN traffic is regular old HTTPS web traffic between you and the VPN server. Now, it's important to note, with the way I'm going to demonstrate this WebSocket connection, the only purpose of the WebSocket is to obfuscate that traffic. The WebSocket is not providing any security here. All of the security comes through the WireGuard protocol, which we're going to set up first. And if you happen to be on a network where you don't need to use the WebSocket portion, you can absolutely just use WireGuard by itself. This video is going to be broken up into two parts. I would recommend following the first half first, set up your WireGuard VPN, and then try to use it. And if it doesn't work, then you can go through the extra work that I'll show at the end of the video of setting up that WebSocket to make this traffic appear like regular HTTPS web traffic. So that's what we're doing today. Now, if you're following along at home, take a look at the description of this video. There will be a link to a web page with all of the commands I'm about to run, and also some links to the tools that we're using. But that should be all of the introduction that we need, so let's go ahead and cut to the desktop. All right, guys, and here we are on the desktop. And just so you know what you're looking at here, I've got a terminal that is SSH'd into our VPN server. This is a server running Debian 11. And behind that, I've got a VirtualBox virtual machine running Fedora 34. This is going to be our VPN client today. So to start off, let's install WireGuard on both of these machines. Now, the WireGuard protocol is part of the Linux kernel. It's a kernel module that is included in the mainline kernel. But we do still need to install some tools that we're going to use to interact with that module. Now, one thing I want to draw your attention to for that module is that you need to pay attention to what kernel you're running. WireGuard has been included in the Linux kernel since version 5.6, and as you can see, I'm currently running version 5.10. However, if I run uname-r, you can see the specific build of the kernel that I'm running right now is a cloud kernel. Now, some server providers, such as DigitalOcean, use cloud kernels on their machines by default, and other providers, such as Linode, use a standard generic kernel by default. In order to use WireGuard, you need to be running a generic kernel. This cloud kernel actually does not include the WireGuard module. So check what kernel you're running with uname-r, and if you're running a generic kernel, then you should be good to go, and you can just run apt install WireGuard to install the WireGuard tools. However, if you are running a cloud kernel, if you're using a cloud service provider that gives you this kernel by default, you're going to want to install the Linux generic kernel, and the package for that on Debian is Linux image AMD64. So since I'm using a cloud kernel and I need to install the regular one, I'll install both of these packages. We'll pull those in. Okay, and this server is going to be a dedicated WireGuard server. I'm going to want to run that generic kernel, and I'm never going to need the cloud kernel again. So I'm going to go ahead and remove it with apt remove linux-wildcard-cloud-wildcard. Now, on a very important production system, you would want to go ahead and reboot into your new kernel before you remove the old one. But once again, since this is a purpose-built machine, I'm just going to go ahead and remove the old kernel. Now, before we reboot into that new kernel, there's one more thing I want to do. We're going to nano into etc sysctl.d/99-sysctl.conf. Now inside of here, I'm going to look up an option called net.ipv4.ip_forward, and that's right down here. We're going to uncomment that to enable IP forwarding. This is going to be important later because this is going to enable packet forwarding for IPv4, which our VPN server will need to be able to do. It needs to forward packets from the client onto their destinations, and it needs to forward them from the destinations back to the client. So you will need to do this even if you're already running the correct kernel. After that's been done, we can go ahead and reboot this server. And when we SSH back in here, we can go ahead and check one more time with uname-r. You can see that our kernel now does not have the word cloud in it. The generic kernel might not say generic, it might just say numbers, or it might say LTS. Just as long as you don't see the word cloud in the release name, you should be good to go on the server side. So that is all of the installation we need to do on the server. Now on the client, it's going to be even a little bit easier than that. Running Fedora here, if we run uname-r, you can see no cloud in our kernel since I'm running Fedora Workstation. So all we need to install is the WireGuard tools package. We'll do that with sudo dnf install WireGuard-tools. And after I authenticate, DNF will spend a few minutes thinking about this operation, and it will go ahead and install the WireGuard tools package. So now that we have WireGuard installed, we want to go ahead and start configuring it. Now when it comes to the configuration here, an important thing to realize about WireGuard is that there isn't technically a client-server architecture with WireGuard. Our server, in this case, it's a server because it's in the cloud and it's always going to be there. Our client here is going to connect and disconnect, and this server is going to be where our client directs all of its traffic. So the client is dependent on the other machine, and that's why I'm calling it a server. But as far as the WireGuard protocol is concerned, the server and the client are equal peers in this connection. Both of them are going to need public and private keys for authentication, and both of them will need some configuration done. So here on the client, we'll start setting up our keys. We're going to run sudo bash-c, and I'm doing that so that I can run an entire bash command as sudo, including some redirection. So we're going to set our umask to 077, which means that any files that we create in this command are going to only be readable by the owner of the file. Anyone else who's not the owner of the file will not have the default read privileges that they would normally get. We're going to run wg-gen-key, so this is a WireGuard utility that we're using to generate our private key, and we're going to save that key in etc WireGuard client.key. So that's going to be our command. We'll run that. Next, we're going to do sudo bash-c wg pub key. So we're going to use this private key to create a public key now. And in order to do that, we're going to pass in the private key that we just created. So we use bash redirection for that. Do WireGuard client.key, and then this key that we're creating, this public key, we're going to save to etc WireGuard client.pub. So we'll go ahead and run that. So now that we've done that, I'm going to cat out the public key that we just created first. So that's going to be sudo cat etc WireGuard client.pub. And we're going to go ahead and copy this public key because we're going to need it over on the server. So we'll come over to the server and we'll run something very similar here. We'll run umask 077. I'm not using sudo on the server because I'm logged in as root, but we'll run wg-gen-key etc WireGuard server.key. And then we'll also run the pubkey command. Once again, we will input our WireGuard server.key file, and we will output to etc WireGuard server.pub. Now here on the server, I'm going to need this private key inside of our config file. So I'm just going to get our config file started by copying etc WireGuard server.key into our new config file, which is going to be etc WireGuard wg0.conf. We're calling the config file wg0.conf, which means that our virtual network interface is going to be called wg0, as opposed to something like eth0 for a physical Ethernet interface. So I'm going to nano into this new config file, etc WireGuard wg0.conf, and this is our private key. I'm going to just move that a couple lines down. We'll use it in just a second. So in our server's config file, we're going to start off by defining that virtual interface. And this config file uses something like an ini format. So our headings will be in square brackets, and then our options will just be on different lines. We're going to set our address for this interface for our server to 172.16.0.1/24. Now, this is going to be the IP address that you use within your VPN. So I'm specifying a 172.16.0 subnet here. That gives me 254 possible hosts I could have, so I could have 253 different clients connecting to my server here. You can use a different IP addressing scheme if you want to. I'm just using 172 because my home network here is using 192. This server is already on a 10. network, so just to avoid any confusion, I always want to know if I'm looking at a 172 address, I'm looking at an IP address that is within my VPN. Next, we're going to set the port that we're listening on, and for that, the option is listen port. I'm just going to use the default WireGuard port, that is 51820. And the next option is private key. And that is going to be where this private key comes in, so I'll just bring that up to that line. So this is all of the identification that we need for this interface. Now, we do need to script a couple of things here on the server because the server happens to be running an IP tables firewall since it is publicly exposed to the internet. In case you're wondering, this server is just a DigitalOcean droplet. But we're going to add a comment here so that I know that these next few lines are firewall rules. And we're going to use a post up option, and this is basically just a command that you're running after you bring this network interface up. So you can put whatever commands that you want on this line. I'm going to paste in a set of commands here, and these are all on one line. They're separated with semicolons, but this is just 3 IP tables commands that are setting up some firewall rules to make sure that our firewall accepts the packets that we are attempting to receive and send and forward. We're also going to add a post down option, and that is going to be, once again, 3 IP tables rules that are undoing what we did before. You can see the first 3 commands use -A to add rules, and the last 3 commands use -D to delete those rules. The next section of our config file here is going to be called peer. And like I said earlier, the WireGuard protocol doesn't differentiate between client and server. It's a peer-to-peer protocol, so we do need to authenticate both ways between our server and our client. So I'm just going to put a comment in here. This is going to be client number 1 details. So the public key for our client, that is going to be the public key that we copied before, and I've used my clipboard since we copied it, so I'm just going to copy it one more time. So this is the public key for the client we're pasting into the server's config file. Next, we want to define what traffic to route to this client. So the option here is going to be called allowed IPs, but what we're specifying here is what IP addresses should be forwarded to this client. So for this, I'm going to say 172.16.0.2/32. So our client is going to have the IP address of 172.16.0.2/32. This is basically saying we need to match the entire IP address, not just a subnet. If you used something like 24, then the server would forward everything for the 172.16.0 network to this client, which is not what we want. The client only has one IP address. We need to be receiving things for .1. Maybe you've got another client that's going to use .3. This client should only receive traffic destined for 0.2, so we're going to specify a /32 subnet mask. That is everything that needs to go into this config file here, so I'll go ahead and save that on the server. And here on the server, I'm going to cat out etc WireGuard server.pub, because once again, we're going to need that over on the client. So I'm going to copy this server's public key, and back here on the client, I'll do the same thing I did before. We'll copy our etc WireGuard client.key file to etc WireGuard wg0.conf. You could probably just rename the file. Honestly, you don't even need the client.key file hanging around after you use it to create the public key. But we're going to nano into that etc WireGuard wg0.conf file. And in here, we're going to do, once again, a lot of the same configuration. We're going to specify the interface here on our client machine, and the interface is going to have an address of 172.16.0.2/24. So once again, this is specifying the network interface. So in this case, we're saying we've got the IP address of .2, but we are on the entire subnet, which is a /24 subnet. Our private key is going to be, once again, the private key that we created before. Now here on the client, I'm also going to add a DNS option, and I'm just going to add our server as a DNS server here on the client. This way we can resolve names against the server if we need to. Now I'll add our peer section, and the peer here on our client is going to be our server. So I'll run public key equals, and we'll paste in the server's public key that I copied before. And next we have the endpoint. And once again, I'm just going to add a comment in our file here. So the endpoint option is just saying what IP address we should expect to reach the server on. Now, we did not specify an endpoint in the server's configuration because the client's IP address on the internet might change. This might be a laptop that you're bringing to different places, and that's why you want a VPN set up in the first place. And it wouldn't be practical to connect to your VPN server out of band every time you want to connect to VPN and update your IP address in the configuration. But here on our client, we do need to know how to contact the server, and since our server has a static internet IP address, we can just use that IP address as the endpoint. So for our endpoint here, I'm going to put in the IP address, which is 64.227.1.103 in my case. We're going to add a colon at the end and the port that our server is listening on, which is 51820. So this port is what you specified in the configuration for your server. The IP address, you just need to look using the IP address command or whatever you want to do here on your server to find out your server's public IP address. Back here on the client, the next option is going to be the allowed IPs option, and that's going to specify the traffic to route to the server. So allowed IPs is going to equal, I'm going to specify a range that will send everything to the server because we don't want to make any out-of-band unencrypted connections. When we have this VPN server active, I want all of my traffic going through the WireGuard server. So for IPv4, that's going to be 0.0.0.0/0 is going to specify absolutely every IPv4 IP address. For IPv6, we'll do 2 colons, which is the equivalent of all zeros, /0. The 2 colons would add zeros in front of any other numbers that you put, but if you just don't put any numbers, then it's all zeros. So once again, just telling our client to send all traffic to the VPN server when we're connected. And finally, I'm going to add a keep alive option here. Now, like my comment here says, you want to use a keep alive if your client is going to be behind a router that's using network address translation, or NAT. The reason why you need a keep alive in that case is because your client always knows how to get to the server. The server has a public IP address that will never change. So once you connect, WireGuard is a stateless protocol that uses UDP. So your server will never close the connection. Your client can just send packets to the server whenever it wants to, and the server can respond back, and that will work perfectly fine. However, if you're ever using any website that might send data to the client spontaneously, let's say maybe you're accessing a Nextcloud instance over your VPN. Nextcloud can send push notifications to the client, but those push notifications, it might happen once every 5 minutes, or you might get a push notification after 30 minutes. Maybe you're sitting on an email website like Fastmail or ProtonMail, and you're waiting for an email to come in, but you don't want to sit there clicking the refresh button. You just want the email website to be able to send the client whenever a new email comes in. In order for that to work, the server has to be able to send packets to the client at any time that it wants to. However, if you're behind a network address translation router like I am right now, if you're on a residential internet connection, you're probably behind NAT. And even if you're on a business connection, you're still probably behind NAT. The router needs to know which client on your local network to forward packets to. So when the server sends you packets, it's going to send them to your home network's public IP address, and it's going to use an ephemeral port to specify which client it's wanting to send that information to. The router actually keeps track of the port that your client used as a source when it was sending information, and it keeps track of that information for a period of about 30 seconds. It might be longer or shorter depending on your particular router, but basically your router has a cache that tells it where to forward responses to on the local network, and that cache does not last very long. So basically what I'm saying is you need to keep alive so that your router remembers which client was communicating with this server using the port number that it's using. So in order to add a keep alive, we're going to set persistent keep alive to 25, And that's going to mean that every 25 seconds, your client here is going to send the server just a very small UDP packet just to keep the connection alive. Now, this is disabled by default because the WireGuard developers want their protocol to not be chatty. But once again, if you are behind NAT, then it is pretty fundamental that you add that. And one quick note about the keep alive, we're going to do some packet captures in a little bit just to demonstrate WireGuard working. And the keep alive will not show up in a packet capture of the WireGuard interface. It only shows up in the packet capture of the physical interface because the WireGuard kernel module is smart enough to know that this keep alive is not user-generated data, so it's not going to process it using the virtual interface. And one other note about the keep alive, a lot of tutorials out there actually place it on the server instead of the client. To me, it makes more sense to place it on the client because the client is the one that's going to possibly be changing public IP addresses more often than the server. It should theoretically work either way, but it just makes more sense to me to put it on the client. It seems like you're going to have less corner cases where it would stop working that way. So we'll go ahead and save the client config file here. So we now have completed configuration on both our client and our server. That is really all that it takes to set up basic WireGuard networking. Now to test this here on our client, I'm going to run sudo dnf install Wireshark, and this is an application that is used for taking packet captures. We're going to take a look at the actual data that we're going to see when we connect to the internet, not using our VPN and then using our VPN. All right, so that's done. Going to open up a new terminal here, and I'm just going to run sudo Wireshark to open up Wireshark with root privileges. And I'm going to start a new packet capture first here on our Ethernet interface. So this is what normally happens when you access the internet. I'm going to open up Firefox here, and we're going to search, thank you Firefox, we're going to search what is my IP. And you can see we've got all kinds of network stuff going on here. Our IP address here on our client is right now a 24 dot address, and this is the address for my Comcast internet connection here in my apartment. And you can see that we're communicating to all sorts of different websites, all sorts of different public IP addresses over the internet here on our Ethernet port. I'm going to close Firefox because it's way too chatty. You can see it talking to all kinds of stuff there, and the Google website probably is as well. And if I just ping 8.8.8.8, so I'm pinging Google, you can see those pings going directly to 8.8.8.8, once again here on our Ethernet network. So this means that my ISP can see that I'm communicating with Google. Comcast can see that. If you're inside of a business and you're using their internet connection, the business or whoever's running their routers can see that. So let's connect to the VPN and let's see what changes here. In order to connect on our server here, I'm going to do it through systemd, and it's very easy to start WireGuard via systemd. We're just going to run systemctl. I'll go ahead and just enable it. And I'll do -- now to also start it. And you can just use the service wg-quick, and then we're going to use an @ sign, and you'll put the name of your network interface, which in our case is wg0.service. I'm going to run that, and we did not get any errors. So if we run systemctl status wg-quick @ wg0.service, you can see that that is running, and you can see that we ran our post up command to open up our firewall. Now we're going to come back to the client, and on the client I'm going to use a different command. It's just another way to do the same thing. I'm going to run sudo wg-quick up wg0. And that is going to set up WireGuard. And at this point, we should be connected. And we can test that this is working very easily by just pinging our server using its virtual IP address. So remember, this server's IP address was 64.227.1.103. That IP address we can always ping. But if we do an IPA, you can see that our virtual interface here has an IP address of 172.16.0.1. So that IP address, that's a private address. That is not routable on the internet. So if we come back to our client, we're going to try pinging that, and if it works, it means that our VPN is working. So let's see what happens. You can see that it is indeed working there. Now back here in Wireshark, you can see these pings happening, but they're not actually showing up as pings. Back when we pinged Google a few minutes ago, you could see it was an ICMP request and reply. Wireshark was able to see what those pings actually were. Now, since we're connected to WireGuard, the protocol here just says WireGuard. We can see the public IP address of our WireGuard server, but we can't actually see the ICMP request itself. This is just encrypted data. Now, if we open up another Wireshark window here, I'm going to do sudo Wireshark, And we're opening up a second instance of the same application. I'm going to run a packet capture on our virtual network interface here on the client. And this will show you what's happening inside of the VPN, since the client is one of the two computers that has the keys necessary to see inside of here. You can see that we are indeed sending ICMP requests and replies. We are pinging, but that pinging is happening inside of the VPN. Publicly, we can't see that that ping is happening. We just see, once again, WireGuard traffic. So that's working beautifully. Back on the server, we can also check if we just do TCP dump-I WG0. I might have to install TCP dump first. All right, so now running TCP dump-I WG0, once again, you can see that our server is receiving these requests from the client. The client is at 0.2, we're 0.1, and we are sending back our replies every second or so there. And once again, on the server, if we run ETH0, this is all of the traffic that's coming in, and I'm going to go ahead and stop that because it's a lot of traffic, but you can see it doesn't say ICMP anywhere. This is all just WireGuard traffic happening on the Ethernet interface. So that's really cool, and that's working. And finally, one last test here in Firefox. We can open that back up, and we can search what is my IP. You can see that the IP address now that Google knows about, if our DNS works here. And I think the problem is that my server is not actually set up as a DNS server. I added that to the configuration earlier, but we're not actually running a DNS server on that machine. So let's come back into our wg0.conf file, and let's just try commenting out. Actually, let's just change DNS 8.8.8.8. So that's going to still use Google's public DNS server instead of our own DNS server. Sudo wg quick down wg0 to take that down. And we'll run wg quick up to bring it back up. So now if we come back over here and let's try going to Google again, there we go, it works now. And what is my IP? And as you can see, Google now sees that our IP address is 64.227.1.103, which is the IP address of our server, not of our client. So that means that this entire thing is working properly. You can see once again back here, let's go ahead and try starting this WireGuard capture again. When we communicate, when we go to google.com here, we see all kinds of stuff happening. We saw a DNS request somewhere in here. Yeah, we see some DNS requests happening in our VPN. We also see some TCP communication happening. But once again back here, all that we can see on our physical network interface is WireGuard traffic. Now this works perfectly fine if you are using a network that is not super restricted. If you are using a network that would let you do anything that you want to do, you just don't want them to see what you're doing, you can absolutely just stop right here. You have a WireGuard server set up, so that works perfectly fine. However, let's say that you're using some sort of public internet connection that's using deep packet inspection to only allow certain types of packets. Let's say that WireGuard traffic isn't allowed. Maybe only HTTP and HTTPS connections are allowed, so you're able to access websites via SSL, but you want to go through a VPN because you don't know if the network that you're on has some sort of proxy that's intercepting those SSL certificates, man-in-the-middle attacks happening, that kind of thing. For that, you need to tunnel your WireGuard traffic inside of a WebSocket connection. So that's going to be what we do next. Once again, entirely optional, and it's adding a lot of complications, so I would only recommend it, once again, if you actually need to. And by the way, I will just point out, if you watch carefully here, like I was saying earlier, for that WireGuard keep alive to happen, the keep alive, you can see it shows up in the Ethernet interface, but it does not show up in the WireGuard virtual interface. That was what I was talking about earlier with that. So to set up this WebSocket thing, here on the server, we're going to start by downloading a program called WS Tunnel. Now I'm going to be copying and pasting some commands for the second half of the video because they're going to get a little bit long, but I will have a link in the description to a page with all of the commands that I'm running so you can take a look at them closer to see exactly what you're doing. And you can also go to these GitHub pages yourself to see what programs we're actually using here. But WS Tunnel is a nice little WebSocket tunneling program. It's not currently in the Debian repositories, so we're just going to download it manually. I'm going to move it into user local bin, and I normally don't like installing programs out of tree like this, out of repo, but once again, this is just a dedicated VPN server, so I'm not too worried about it causing other ramifications or anything. We're going to make that new program executable, and I'm also going to run a set capability command that is going to allow this program to bind to what it needs to bind to in order to tunnel everything that we're sending and receiving through a WebSocket. Next, I'm going to install a service file, and that service file is going to look like this. So this is just a regular old systemd service file. We've got a description. We're starting it after network.target. So if we attempt to start this service file and network.target isn't running yet, that's not going to work. We need to make sure that network.target is running first before we start this service. The type of the service is simple. That means we're just running a command. It's not running as any particular user, but the command that we're running is WSTunnel, verbose for better logging. We're starting a WebSocket server, and that's going to be listening on any IP address on port 443, which is the typical HTTPS port, and we're going to restrict it to 127.0.0.1:51820. That's the port for WireGuard. So we're starting a WebSocket tunnel, and anything that is coming into this machine on port 443 will be forwarded to its destination, which is going to be the local WireGuard server. And then anything going out on port 51820 will be sent via this WebSocket tunnel, while all other traffic will go out normally to its destination on the internet. We'll set restart equals no. The service should never really stop anyway. And under install here, we're going to say wanted by multiuser.target. That's just going to start this service automatically when the system starts up. If the service is enabled, which we're going to do right now, I'm going to enable it with -- now to also start it immediately. Now we're going to come back over to our client, and on the client, I'm just going to run sudo wg quick down wg0. We're going to take that VPN offline for a second while we set up this WebSocket tunnel. I'm going to download the same program that we downloaded on the server. I'm going to move it into place once again. I am going to mark it as executable. We don't need to run that set capability command because we're not binding to anything here on the client. We don't need those special permissions to send things through a WebSocket. We only need those special permissions to listen on any network interface like the server's trying to do. Here on our client, though, we do need to do an extra step in terms of configuration. Now, I'm going to download a bash script right now, and this is typically a bad idea in principle, just downloading bash scripts, but we're going to take a look at this bash script, wstunnel.sh. This is setting up routing, and there's really not a good way to get around this right now. You can read the explanations for everything that's being done if you go to the GitHub repo of this user who has created this script. It was originally created on one repo, and then I've just downloaded basically a fork, which uses the IP route command for configuration instead of some older commands in the original script. But this is going to set up the routing table on our client to say if we're sending things through WireGuard, we want that to go through WebSocket connections. Now inside of this script, there's actually something we need to change here. And if I scroll down until we get to this remote IP section, you can see that what this is going to try to do is bring in a remote host from the configuration file that we're about to create, and it's going to set that to a variable called remote. Then later, it's going to set a remote IP address to the output of the dig command, and it's going to pass in that remote variable. So it's going to try and look up an IP address for us using a domain name. Now, if your VPN server has a domain name, that's perfectly fine. You do not need to edit this file like I'm doing right now. However, if your VPN server just has an IP address like ours does, this dig command is going to give you an error because you're attempting to look up the IP address of an IP address, which isn't what the dig command is made for. The dig command is made to look up the IP address of a domain name. So it's going to say, well, I can't find the domain name 64.227.1.103. That domain name doesn't exist. It's not in the DNS system because it's not a domain name, it's an IP address. So ordinarily this script, as you can see, if it can't find a remote IP, it's just going to exit. What I'm going to do here is instead of exiting, we're just going to set remote IP to remote, which means basically if you attempt to look up the IP address of this configuration option and you can't find it, just try to use the actual configuration option itself as your remote IP. I'm going to save that. We are going to move this wstunnel.sh file into etc WireGuard, and we are going to mark it as executable. And then we are going to go in and configure our WSTunnel. So we are going to set this up at etc WireGuard wg0.wstunnel. So you want wg0 to reflect your interface name. If you used a different name for your network interface, you would put it here. Inside of this wg0.wstunnel config file, we're going to add two options. The first one is remote host, and that is going to be 64.227.1.103. So once again, this could be a domain name, and if it's a domain name, then you don't need to do that previous step I just talked about. But the reason I did that was because we're passing in an IP address. We don't need to convert that to an IP address that already is one. Next, we're going to add remote port, and that is 51820, once again, our default WireGuard port. Now, if you're using a domain name instead of an IP address, then you're going to want to add a third option called update hosts equals, and you're going to want to put a path to your Etsy hosts file. That's probably the path you're going to want to put in unless you're using a different resolution file on your system. So you need this option if you're using a domain name, because the whole DNS lookup process when this is being set up might not work like it normally does. So this script is going to add a DNS entry in your hosts file for you to work around that problem. Since we're just using an IP address, we don't need to do that. So we're going to comment that out, and I'm going to save that config file. Finally, inside of our Etsy WireGuard wg0.conf file here, we're going to change the line underneath endpoint here. We are no longer going to be sending traffic in WireGuard directly to the server. Now we're going to send it to our WebSocket tunnel, which is 127.0.0.1:51820. And underneath the interface section back up here, we're going to add a few more lines. We're going to say table equals off, and we're going to add in a pre-up, post-up, and post-down command. So before bringing this WireGuard config file up, we need to run our wstunnel.sh script to run some pre-up operations, once again setting up our routing for that WebSocket tunnel. After this interface has been brought up, we need to run the same script, but we're going to run some post-up commands. And then after we take this down, we need to run some post-down commands to put our routing back to normal so we can use our computer on other networks. So we're going to save that file. And I know that's a lot of stuff that we're not exactly looking at line by line here, but this is basically programs that people have written. People have gone through the work of creating these scripts themselves. I'm just showing you how to set it up, and we've done everything that we need to do at this point. So let's try starting our VPN once again. I'm going to run sudo wg quick up wg0. So at this point, let's check out where we're at. Can we ping our server 172.16.0.1? Looks like we cannot ping that server yet. Did I restart WireGuard on the server after we set up that WS tunnel? It doesn't look like I did, so let's just try doing a systemctl restart wg quick at wg0.service. Can we ping our client from the server? Destination address required. All right, so let's take a look at what might be going wrong here. Systemctl status ws tunnel. Looks like that actually failed to start. Interesting. Systemctl start ws tunnel. Permission denied. All right, let's do an ls-alh on user local bin ws tunnel. And it looks like, I'm not quite sure what the problem is. We're executing that systemd service as the nobody user, like I said. If we cat out our Etsy systemd system ws tunnel.service, that's running as nobody. And I can see that right now root, the owner of this file, has access to execute, but nobody would probably not because the other permissions are nothing. So let's just do chmod +x user local bin ws tunnel. I thought I did that earlier, but looking up at my commands, well, I definitely did. What if we do O+X? All right, so that added the ability to execute for other users. So can I go ahead and systemctl restart ws tunnel now? If we do status, okay, so it's running now. So now I can go ahead and ping our client. Yep. And I can come back to our client and I can ping our server. So now it's working. And now if we take a look at what's happening over on our Ethernet port, you can see this is no longer showing up as WireGuard traffic. Before, the protocol here said WireGuard. Now it says TLS v1.3. If we take a look inside of one of these packets here, you can see transport layer security. It says application data protocol, HTTP over TLS. So this is showing up as HTTPS traffic. It's just encrypted data like you would be sending to any old HTTPS website. Now, a decade or longer ago, you might have had some networks blocking HTTPS traffic because they couldn't see what's inside of it. But nowadays, that's not really feasible for public networks to do because so many websites out there require HTTPS. And in this case, even if somebody did have some kind of proxy running to man in the middle your HTTPS connection, which is possible to do, Once they get in there, they're not actually going to see your VPN traffic. They're just going to see, well, your encrypted VPN traffic. They're going to see WireGuard data, even if they go through the extra effort of decrypting this HTTPS data. And they're not going to be able to man in the middle of WireGuard data because they don't have the keys that your server and client are using in WireGuard. But this setup should get around simple deep packet inspection systems that are only allowing certain types of traffic. If you're using a public network on an airplane or at a coffee shop and they only allow certain types of data for security, quote unquote, this shows up as HTTPS web traffic, and it's all just going between you and the VPN server, 64.227.1.103. Once again, if we come back over here and we start our VPN wire capture, we can see the actual data. Once again, only you, the client, and the server can see this data that's inside the VPN. But yeah, we can go ahead and go back into Firefox, and we can go back to google.com. And you can see, once again, all of this data it's being obviously generated inside of the VPN. But as far as our Ethernet connection is concerned, if we do what is my IP, there's all kinds of traffic going right now, but it's all just showing up between you and the VPN server. And our public IP address is showing up as the IP of the VPN server. So we had a couple of bumps along the way there. This process is a little complicated, but that is how you can set up a WireGuard VPN server and client using WebSockets. And if you want to add more clients, all you have to do is replicate the configuration that we did here on the client, and the server should be able to handle more clients as well. So hopefully that demonstration was useful to you. If it was, feel free to go to nerdclub.knots.co and consider joining the Nerd Club for just $3 a month. It helps me make more videos demonstrating free and open source software like this. And if you have any questions about this, feel free to ask them in the comments section below or at the forums at nerdonthestreet.com. But for now, that's everything I wanted to show you today. So I'm Jacob Kaufman, I'm the Nerd on the Street, and I'll see you guys in the next one. Bye.